Now I'd like to present you some work we have done on secure task-based programming with OmpSs and SGX. On the context of this work, we have implemented several applications to illustrate how this integration works. So today in this demonstration, I will be focusing on one of those applications, which is a matrix multiplication. I already have here the code we have written for this application, and as you can see we have three different versions of it. One original one which does not consider any OmpSs or SGX, another one which relies on OmpSs for the parallelization and SGX for the security, and yet a third one which will be adding encryption to the top of that. So if we start by looking into the original version, we can see here in the code that it's a simple implementation of matrix multiplication where we have a function init putting random values in the input matrices, and then a compute function which is defined here up here, where as you can see you just iterate through the dimension of the matrices, and then you call the matmul function, which will be the one responsible for actually doing the calculation of the multiplication and storing it in the matrix result. Then another part of the code we have added for the purpose of illustration here is this part here where we have a password string being loaded to the memory, and then we will be using this script here, search pass, which looks for password in the memory of the given application PID. So if we go ahead and we compile this version and run it by giving as input the size of the dimension of the matrix and the block size, here I will then run my search pass script, which will be looking for the password, and the idea is that here it will be able to find it, but after, yeah, here you can see that it found it, and afterwards for the SGX version what we expect is that this will no longer be the case. So here now if I let it compute the actual multiplication, we can see that it takes about a second in this original version. And now if we move to the SGX, OmpSs SGX version, what we can see in the main application is that the code looks very similar. So as you can see, you still have this init method, and the iteration through the matrix is already done directly here, where we call the matmul function again, which is now an equal. From the OmpSs point of view, the only change that is needed is that now before each matmul function call, we add the pragma to a OmpSs task, and we indicate what is input in this task and what is output. And then also afterwards we need one extra pragma to say that we need to wait for all the tasks to continue before we move on and give the result as output. And if we look how this implementation of the matmul looks like in the enclave side, so first of all there is the EDL file where we define basically how the function should look like, the signature of the function, and then the implementation itself, which as you can see consists just of the same code we have seen before, where the multiplication is performed, and here before where the password is loaded to the memory as well. So now if we compile this code, we can see that the enclave has been created with all the configurations that we can predefine, and now we can run it. As we have the SGX version, now we can define the number of workers, which I will initially put to 1, and use the same parameters as before. So now I have this PID, which I will again give as parameter to my search pass script here on the right. And I will just go further with test. So now we also expect it to take a bit longer because there is the overhead that SGX gives to it. So yeah, as you can see now we finish with now 3.6 seconds, while before we had about 1 second. And the search pass script failed to find the password, although it was loaded to the memory as you see, but in the enclave side. And now next thing to see is like how the OmpSs tasks parallelization can help us to mitigate this problem of the overhead here. So I will try now the same application with 2 threads, and let's see what we get. So yeah, now you see that we already reduced quite a lot the duration of this application. And if we go to four threads, then we can probably observe even a better result, which is, yeah, indeed the case. So here we have again something about 1 second, what we had before in the original version, even a bit less in this case. So this shows how we can easily add parallelization to an application that uses security, and through that reduce the overhead that SGX has. That's it for this demonstration. Thank you for your attention.